So now let's get into solving a radical inequality. Now with a radical inequality, it's not just one answer you're looking at. You're looking at a whole range of numbers. And so we have 3 square root of x minus 1 is less than or equal to 12. Now when we're trying to solve something like this with an inequality, we have to think of, number one, what is our index of our radical? So the index of a radical is even, right? It's a square root. Now, what do I have to remember about square root values? Can I have every number? No, I can't. I cannot have anything that's negative. So in this case, when you have, for instance, square root of x, x can only be greater than or equal to 0. Think about the graph, square root of x, it's this. And so remember our domain is x is greater than or equal to 0 and y is greater than or equal to 0. Then we can shift it left or right. So before we even go on, let's think about that. We've talked about domain and range and graphing. We have 3 square root of x minus 1 is less than or equal to 12. We have to know what is the lowest value we can plug in here? Well, can we have square root of 0? Is that allowed? Yes, square root of 0 is 0. So what we do in order to solve for the restrictions, these have restrictions, is that you take these square roots and it has to be greater than or equal to 0. Okay, it has to be greater than or equal to 0. And actually, I don't need the square root. Let's just do x minus 1. Has to be greater than or equal to 0. So here, x has to be, if you solve for x has to be greater than or equal to 1. Because look at it. If I plug in 1 into this equation, 3 square root of 1 minus 1 is at less than or equal to 12. So 1 minus 1 is 0. 3 times 0, that's less than or equal to 12, and that's true, right? So whatever it is, we know that 0 or 1 is the smallest number I can plug in. We can test it out. Has to be greater than or equal to 1. Like, what if I plugged in 0? 3 times square root of 0 minus 1 is less than or equal to 12. Well, that's 3 square root of negative 1. Now, that is not allowed, right? We can't have a negative in this square root. So it's true. X has to be at least greater than or equal to 1. All right. So we know our restriction is x has to be greater than or equal to 1. Let's solve this normally now. So to solve, we're going to divide by 3 first. We're going to isolate our square or radical first, just like we've done before with equations. 12 divided by 3 is 4. So now we're going to square both sides to get rid of the square root. X minus 1 is less than or equal to 16. We're going to add 1 to both sides. So x can be less than or equal to 17. Now what this means is I can have any number that's less than or equal to 17. Now is that really true? No, because we have to remember that x has to be greater than or equal to 1. So really, we know that x has to be less than or equal to 17 this way, but the lowest that it can ever get is positive 1. So we need to have that restriction there. So that means is that x can only be between 1 and 17. And so that is our answer to this inequality. Okay, so again, it's because we cannot have a negative inside of the square root that we have to restrict it. And so we can't have everything to the left. We have to stop it at positive 1 because that is where it's 0, and that's okay. But if we go less than 1, then we get into negative inside, and that's imaginary. You're not allowed to do that. So go ahead and try these 2 examples here. Pause the video and see if you can do it on your own. All right, so looking at this one, my restriction, let's see, square root of x, that is an even index. So that means x has to be greater than or equal to 0, whatever my answer is. Now, let's solve. 2 square root of x minus 3 is greater than or equal to 3. Add 3 to both sides first. So 2 root x is greater than or equal to 6 divided by 2. So square root of x is greater than or equal to 3. And then let's square both sides. So x has to be greater than or equal to 9. So x has to be greater than or equal to 9. And so that means it's going to the right. So we don't have to consider our restriction. x has to be greater than or equal to 9, which is that direction, and so that's the only solution there. You can test it by plugging in a number greater than 9, so let's do 10. No, let's plug in a number that is a perfect square root. So let's plug in, 16? 2 square root of 16 minus 3, is that greater than or equal to 3? So 2 times square root of 16 is 4, minus 3, is that greater than or equal to 3? So 2 times 4 is 8 minus 3, and so 5 is greater than or equal to 3, so that is true. Okay, so I want numbers that are bigger than that. All right, number 11, B. So we have 4 cubed root of x plus 1 is less than or equal or less than 8. So in this case, it's odd index. Remember the graph of a cube root. It's this, and this is all real numbers. So we don't have to worry about any restrictions, right? We can have any number. We can have negatives in there. It's totally fine. So to solve for this, let's divide by 4. So cubed root of x plus 1 is less than 2. Cube both sides to get rid of the cube root. X plus 1 is less than 8. Subtract 1. So x is less than 7. And so you just need to pick a number that's less than 7. Let's pick, we want something that's perfect. What if I pick 0? 0 is less than 7. So cube root of 0 plus 1. So 4 cube root of 1 is 1. So 4 times 1 is less than 8. So that is true. So x is less than 7. Again, no restrictions because it's a cubic. There is a restriction here because it's an even index. Even indexes, you're not allowed to have negative inside of the square root or fourth root, whatever it is.